Welcome to Datadog Illuminated. MCP servers are everywhere right now. They let AI agents access tools and data that they couldn't reach before. But here's the tricky part. When you build an MCP server, you don't control the agent that's calling it. So that agent could be Claude Code, it could be Cursor, it could be something else completely. And here's the other tricky part. You don't know the underlying LLM that agent is using. So your MCP server could be powered by the cheapest model available or the smartest model available or anywhere in between. You're designing for a very general space. So then how do you build something that works well for all of the very specific use cases that come up? Well, Reilly Wood and the Datadog MCP team have been figuring this out. They've built Datadog's MCP server from scratch, and along the way, they've learned hard lessons about what makes agents behave and what makes them fail miserably. So how do you keep an agent efficient when the context windows vary so much depending on which model you're using? How do you prevent tool overload? What tricks actually help guide an agent towards self-correction? So stay with us as Reilly answers these questions and more. Let's do this. Our guest today is Reilly. Reilly, will you introduce yourself, please?
Yeah, I'm Reilly Wood. I'm a staff engineer on the MCP team at Datadog. So MCP is Model Context Protocol. I work on our MCP server for customers and also helping people build MCP servers internally.
I'm quite a consumer of MCP servers. So I'm going to talk about, as a user, how I think it works. And then I'd like for you to verify or clarify.
That sounds great.
Cool. So this is me. I'm an MCP server user. And then in my case, I'm talking to coding agents. I'm a Claude Code fan, but it could be Cursor or whatever. And then when I want to get information from my Datadog backend, or I want my agent to have that information, the agent calls the Datadog MCP server. And the agent asks for what it wants. And in my world as a user, it magically comes back and gets what it wants. And then I have it available to me in my coding environment.
That's exactly correct. That's how our server is typically used. So it's exposing functions or tools to the agent to do things like query Datadog logs or metrics. Sometimes, this stuff is kicked off automatically. People build all kinds of interesting workflows where maybe a monitor goes off and then they automatically start an agent working with the MCP server. But typically okay. there's a human there.
It's probably good to say that this is how you're accessing information from the Datadog backend, yeah? Before we dig into how to tips and tricks about building this MCP server, what would you say is a difficult problem?
I think what the biggest problem I face is just that we don't know a ton about the agent, that thing in the middle. It's often Claude Code, sometimes Cursor, sometimes totally custom agents people are building themselves. And it could be using really any LLM in the world. It could be using something really underpowered or something really powerful. We just don't know. That's my biggest problem these days.
So there's just so much that could be happening here, and you're trying to make any scenario work or optimize for this general thing that isn't clearly defined.
Yeah.
I noticed too that success is a happy user.
Yeah.
But then, you never get to talk to the user directly. Again, with this wily agent.
It's kind of intermediated by the agent. Yeah, it can be kind of tricky to measure success when we're not actually talking directly to that user.
It's all about taming the agent. And really, the agent, yes, but also the LLM underneath the agent.
Yeah, for sure.
So really, we want not just correct answers, but we want efficiency too.
Definitely, yeah. That's one of the big things we try to focus on. I think there are a few high-level areas that we try to tackle to, make the experience good for any agent. And one of the big ones is efficiency. Specifically, LLMs have a pretty limited context window, and we need to be really careful with it. We need to be as efficient as possible, use up very few tokens, because that'll help any agent, any LLM, really.
So context efficiency is a big deal when you're thinking about creating an MCP server. How do you begin to manage that?
There are a few kind of tricks you can do. I would say the simplest one we stumbled on early is be really careful about what format your tools return, because the MCP server has a bunch of tools. They return data that ends up in the agent's context window. We started with really simple, basically API wrapper tools where, we have APIs that return JSON, and then our tools just wrapped those, they return JSON. And that was actually not great. It turns out JSON has a lot of brackets and commas and all of that. And but those actually add up. We found out that, if we return YAML instead, or sometimes CSV, we can return like the same data in remarkably fewer tokens. YAML's pretty good because it maps directly to JSON. It can handle nested objects. CSV is even more token efficient, but it only works for sort of flat tabular data structures. So we kind of pick between them. Some viewers may be familiar with a project called Tune, like token optimized object notation, and it basically does the same trick. So that's been really useful for us.
Oh, I haven't heard that. Tune, T-O-O-N. So you're being really deliberate with data formats to minimize the amount of tokens used.
Another thing we found out is that agents kind of need some way to control what ends up in their context window. To give a pretty concrete example, Datadog has logs. Logs can have like custom fields on them. So a log might have a message, but it also would have like a status, and maybe people append things like the version of their service to each log. And, we started out by like returning every single one of those fields or columns when agents were querying logs. And then we started moving towards letting agents, pick and choose what they wanted. And eventually this kind of grew into a way more sophisticated system where we actually let agents write SQL, like SQL, the database query language. So they can select exactly the columns they want. They can also like sort of group by and aggregate things in certain ways. And it lets them, control exactly what's going to end up in their context window. So that's been pretty powerful as well.
And what's been really interesting as LLMs become the thing, older technologies like SQL have actually become popular because there's a lot of use cases to train on. It's better sometimes to have your LLM work with something older that's very well known and well understood than a fancy new technology.
Yes, 100%. When we started, we were like, oh, we don't really know if, these things are going to be able to write SQL really well. And then they did it way better than us.
So agent controls over context. So instead of getting a whole database, every column in a table, every bit of information, when it just wants one little thing, it can now query for just specifically what it wants. The context in general is like a dance of how do I get exactly what I want and nothing more. And so letting the agent have control over that makes a lot of sense. Mm-hmm. Is there anything else we want to add in this category?
Final point would probably be we put a lot of time into making our tool descriptions good for agents. And that's a really tough sort of like design exercise almost because, we add descriptions to our tools and those help agents call the tools better. But, every word or every token in the description, it adds up, right? It takes away from the agent's context window. We keep trying to like refine our descriptions and make them useful but succinct, right? Like as short as possible. And then like another big category that I think of is we try to keep the number of our tools down and give people ways to pick and choose from tools. The reason for that is we've found, and a bunch of people have found that, agents do very poorly when you give them a lot of tools. Kind of like the same as humans, if somebody asks me to pick between 100 different options, I'm probably going to do a lot worse than if they ask me to choose between 4.
Just like to level set briefly, the Datadog MCP server or any MCP server is managing lots of different tools that the agent has access to. And these tool descriptions are how the agent understands what tools it has access to. And then in general, can you say like with MCP tools generally, or MCP servers generally, how many tools do they usually supply?
It really depends on, what kind of functionality they're exposing. An MCP server could expose one if it's like some really simple functionality, could be like 100.
Isn't there a limit to how many the agent wrapper can even support?
A lot of them have hard limits. It varies quite a bit. I think the general rule of thumb is you want to keep it pretty low because these agents, they run into trouble with like sort of degraded performance, like well before they actually hit the hard limit.
That makes sense. Plus, I know when I'm using the Datadog MCP server, it's not the only MCP server I'm using.
Yeah.
I have other MCP servers and other tools. If one is a bully and takes up too much, I might install it. You know what? I'll do web calls for that. Yeah. Yep. There's a lot of data that can be accessed in your Datadog backend. How do you minimize the tools?
We don't always know a lot about the agent. Sometimes they might be doing really specialized stuff with Datadog, sometimes not. The way we try to make this work is by default, agents get sort of a core or like simplified tool set. It's got the most popular Datadog products like logs and metrics and traces, and it's pretty good at, doing the most popular things people want to do, like investigate incidents with that telemetry. It's designed for like the 80% of what people want to do with Datadog. We also let people pick more specialized tool sets. They can just basically change the URL that they connect to, and then they get different tools for more specialized products like synthetic testing. They're bundled. So yeah, you might say, hey, I want the synthetic synthetics tool set, and you get like 5 different tools for, viewing and creating and editing synthetics tests. Lets users, plug and play. If they don't use synthetics, they don't pay the cost.
Well, that makes a ton of sense. As a user, I appreciate that too. And how else can we keep the agent and the underlying LLM well-behaved when we're building an MCP server?
We want to invest a lot in really guiding the agent, sort of nudging it in the right direction. Agent agnostic, I would say. One big example there is we let agents search Datadog documentation. We actually have a special tool called search docs, and that does a RAG or retrieval augmented generation search over Datadog docs when given, a sort of plain text input.
So there's a specialized search docs tool, and then that's superior to having it look at web documentation because you're giving it all the documentation in RAG in embedded and vectorized format that it can easily access and understand.
Yeah, from the agent's perspective, it needs to do less work. Instead of reading through 5 different docs pages and putting all of those in the context window and using up a lot of tokens, it just makes one call to this tool and gets a pretty short, answer back about exactly what it needed. And there's kind of a trade-off here, right? Because in theory, we could put all of that information in the tool descriptions, but then that uses up tons of context window, and we can't really predict exactly which specialized knowledge the agent is going to need. So this lets agents, pull in very specialized Datadog knowledge when they need it without paying the cost up front.
Do you find because this tool exists, the agent is more likely to look at documentation rather than just guess at what to do?
Yeah, totally. That's a big thing. Yeah. It does help reduce hallucinations just by making it easy for them to look
just
up.
Just with people, you make the right thing to do, the easy thing to do.
Yeah. The other thing we've done is we've invested a lot in our error messages. That's something that helps with humans too, but we did it because it really helps with agents here. To give you an example, for a while we noticed that one of our APIs, I think it was a metrics one, you'd give it sort of a query in a slightly invalid format and it would return a really generic error message 500 error, can't do anything. And then, agents would see that and just kind of give up. They didn't know what to do next. So we put some extra time in and really polished the error messages there. And now it's the syntax of this query is invalid at this point. Did you mean this instead? And then agents can really course correct based on those better error messages.
Yeah, that makes sense. Actionable error messages. Once an agent gets a thing wrong in one way, even new instances, sometimes it seems to get really attached to a wrong way of doing something. And so if you can, especially early on, point it somewhere else, then it seems like that could solve a lot of problems.
Agreed.
So actionable, I didn't need to write. We'll just say actionable. Okay.
Yeah, I think one more thing. There's a feature of MCP called server level instructions. I think this is relatively underused, but instead of, putting all the descriptions and information on individual tools, you can actually put some higher level information on the server at the server level. And we've found that to be pretty useful for nudging agents to do sort of workflows that involve multiple tools. One example here is the search docs tool, right? We really nudge agents to use that docs tool if they're uncertain about anything before calling other tools. And then we're putting together, a few sort of multi-tool workflows, hey, if there's an incident and things are broken, maybe you want to look at logs first, then metrics, traces, that kind of thing. So it really helps agents chain these tools together in better ways.
If you can get it to use the docs, especially it's staying current and it's also just acting smartly. So 2 big benefits to that. And so you can help it know at the server level, hey, do this. But you can also help it know at the server level when to chain multi-tool calls, what some good example workflows are. Awesome. I kind of hope you know more information because I filled the board. So you've been working on building this MCP server for quite a long time, yeah?
Yeah, since the middle of last year.
Okay. The middle of last year in AI speak is 10 years ago. These lessons, I imagine, are hard ones.
Changing so fast.
Is it true that the Datadog MCP server doesn't know the underlying LLM? There's no way to know that, right?
That's correct. Yeah, we get a little bit of information, sort of the name of the agent. That doesn't necessarily imply the LLM. If we could be told that, hey, it's Claude Code, but they could be using, the cheapest Anthropic model or the most expensive. We have no idea.
And you don't know. One last question I have before we wrap up here. I'm really interested in this arrows that casually say oh, this talks with this talks with that. Where's the Datadog MCP server running? What protocols are being used to access all of this stuff?
The Datadog MCP server, it's living on the Datadog side. It's running in one of our data centers, and then the agent talks to it over HTTP. So you can think of it as like a specialized, API or a web API service.
So it's talking over HTTP, and then Datadog hosts this. I think all of this is the answer. But was there a world where you just considered, hey, can we call this via web? Do we need an MCP server? Like, what does the MCP server provide?
I think that what the MCP server provides is it lets us provide a very specialized API surface for agents. We started out by, just seeing, hey, how far can agents get if they just call our regular APIs directly? And, they're getting better at this every day, but they just weren't great at it, right? Because our API surface was not designed from the ground up for agents. It wasn't designed from the ground up at all, right? It kind of grew organically. MCP lets us, start fresh and design things for agents from the start.
That makes a lot of sense. So the web is designed for human consumption, and being able to access things through MCP with context efficiency, noting tool sprawl, and guiding the agent is really helping keep that wildcard layer in check. Well, this has been a really fun discussion. Thank you so much for sharing your time and your expertise today, Reilly.
No problem. Thank you, Whitney.
Awesome. Bye, everyone. Thank you so much for watching.